In this video I'm going to show you how to find the inverse of a radical function. We start off as normally by switching x and y and solving for y. So in step 1 we write it like this, and now we have to isolate y. So now we square both sides and we isolate y and then divide everything by 2. So we add 6, divide by 2. So the inverse function of the original radical function is a piece of this parabola. So which piece? So I need to decide where to cut it off. So the vertex is at 1. We can see that from this vertex form. So do I cut it and keep the piece to the left of the vertex or to the right of the vertex? So basically, do I restrict its domain to be x greater or equal to 1, or x is less than or equal to 1? To answer this question, let's consider the range of the original function. So when you subtract a radical from 1, the values can get only smaller. So that means the range of the original function g is all the values less than 1. So we know that domain of the inverse function is the same as the range of the original function. So this is the reason why we're going to keep the piece of the parabola to the left of 1. Now when it comes to graphing, let's graph the original function first. So let's rewrite g of x in a form that we can recognize all the linear transformations. So here we have negative radical 2x plus 3 plus 1. So we interpret this as a vertical flip, this as horizontal compression, this as horizontal shift to the left, and this is vertical shift up by 1. So we start with the original parent function, y equals square root of x, and then compress it 2 times. So this is y equals square root of 2x, and then shift it 3 units to the left, 1 unit up, and flip it. So the graph will look something like this. So this is the graph of g of x. Now when we graph the inverse, we can either use the relation between the two and just simply reflect all the points that we obtained for g of x and reflect them through y equals x. So that means this point, negative 3, 1, will become 1, negative 3. This point, negative 1, will become negative 1, negative 1. And the graph will look like this. Right, so we can do that just by simply reflecting the graph of the original function through y equals x. Or we can look at the vertex equation of the parabola in the vertex form and take advantage of that format. So looking at this equation, we know the vertex is at 1, 3. Should be 1, negative 3. So we look at the vertex, it's at 1, -3, because here I made a mistake. This should have been 2y plus 6, and therefore this will be -3. And notice how we were able to catch our mistake by approaching this problem from two different angles. So the vertex is at 1, -3, and it's going up. The vertical stretch is 1/2, meaning it's a compression, and it will look exactly what we already have. So this is how you find the inverse and graph the graphs of a function and its inverse on the same coordinate plane.